C# strings are immutable, right? What if I told you that we can change the contents of a string literal at runtime, and because of string interning, that change can affect other places in the program? In .NET, a string is a reference type, but it behaves like a value in many ways because it's immutable. One optimization the runtime uses is string interning. Interning means identical string literals in your program are typically stored once in memory. Every usage of the same literal references the same instance. Two identical string literals can literally be the same object reference. But casing changes the content, so it's a different string. The CLR maintains an internal table or a lookup structure for strings. When the runtime loads metadata and JIT code, it can ensure those literals map to a single managed string object. Now, there is a confusing API in .NET, String.IsInterned. It doesn't return a boolean. Instead, it returns the intern string instance if it exists, or null if it doesn't. The first line obviously is true, but why does the second line return false? Well, that's because when we construct a new string from a char array, the string is created in runtime, so the compiler does not know how to intern it. Therefore, it won't be automatically in the String.Intern table. Interning is mostly about literals and sometimes other strings the runtime decides to intern. But don't assume that all equal strings are interned, only those explicitly interned or loaded as literals. If you want a runtime string to share the same interned instance, you can call String.Intern. After intern, interned string is now the canonical interned instance for that value. And now for the cursed part. Strings are immutable by design. The runtime, the JIT, and the libraries all assume string contents never change. That assumption enables optimization everywhere. But if you use unsafe techniques and take a writable reference to the memory back in a string, you can modify it. A .NET string is stored as an object with a header, a length field, and then the UTF-16 characters. When we use AsSpan and MemoryMarshal.GetReference, we get a byref pointing at the first character in that buffer. So we can change it. And Unsafe.Add does pointer arithmetic, so we can override the internal char array one by one. Now, if we run this, any code that prints text will in fact output blah. Although we are doing it, this is not supported. It can break the runtime's assumptions, corrupt hash tables, because strings are commonly used as dictionary keys, break security boundaries, and crash your process. If you mutate an interned string literal, you may be mutating a string shared across your program. Anywhere that literal appears could now print the new value. That's why interning is safe only because strings are supposed to be immutable. To summarize, string interning saves memory and can improve performance. String.IsInterned lets you check if a string is in the intern pool, and String.Intern lets you add one. But mutating strings through spans and unsafe APIs is purely for educational and experiments, not for production. If you want more low-level .NET tips like this, subscribe and I'll see you in the next one.